Oh, I didn't write this. This is the same as this. It's just a different.
All right, let's get started. Did you pick up a piece of blank form right there? I solved the problem with you. On the back side, you have the table. You should practice solving this correctly to get a utility requirement. You notice here, that is the largest heat deficit in this column. So you move to QH mean. There's no cooling water required. So this problem has no pinch. Pinch point exists only when you need both heating and cooling utility. Now, I will explain the principle how you match process stream correctly. First, this problem at minimum 3 hot, 4 cold, only heating utility, no cooling utility, -1, you have 7 units, 6 exchanger, 1 heater. Where do you put a heater? I emphasized last time. I'm going to explain one more time. You look at this heater I put up in this block. Why is that? Steam is the high temperature hot stream. So, you want this average block temperature for this heater, the highest among the cold block. Why you put heater on cold stream 2? It's likely your H will be here. What would be the average temperature? Right there. Lower than this average heater block average temperature. You put that on this cold stream, average block temperature much lower. So, you always put steam heater on the high temperature portion of cold stream, giving you the highest heater block average temperature. This is the first one. Now, the way you match the problem is highest temperature hot stream match with highest temperature cold stream H1, C2. You can also go from bottom up. Lowest temperature cold stream right here. What is the lowest temperature hot stream? Right there. The way you do it, you can go from bottom up, followed by top down. The goal is to take care of a few blocks as soon as possible, then for leave the remaining decision easier. So, you look at this total area here, 1197, 238. 238 is above 221. 66 is about 38. So you can match those two streams. The way you do it, cold stream, low temperature portion is this cold stream. Low temperature portion of hot stream is this hot stream, which has the smaller area, 1197.12 compared to 1554. That means I can fully take care of E1 by exchanging heat with low temperature portion of the cold block, lowest temperature portion of cold block. So, 1197, I put a temperature here. This 179.84. E1. So, this follows the thermodynamics. Low temperature portion of cold stream. Exchanging heat with low temperature portion of hot stream, number one. Number two, you want to fully taking care of the smaller block. Now you see 238, 179.84. this temperature difference is, this temperature difference above 11 degrees, that's okay. 66, 38, temperature difference above 11 degrees. So this two block is okay. Now, I want to go about second coldest block. That's this one, right? Second coldest hot block, this one. So, look at the temperature, 93, 66, more than 11 degrees delta T mu. 244, 138, more than 11 degrees. Now, this is smaller one, 996.48. Let's take care of this. Call it E2. Where do you put it? Bottom up. 212. 212.77. This area is 996.48. This area is 1197.12 kilowatt. So I take care of two blocks by going from bottom up. Lowest temperature, second lowest temperature on the top side, lowest temperature hot stream, second lowest temperature hot stream. Now, how about this block? This E3 is the highest temperature portion of cold stream. You should match that what happened? Okay. Ow! Not good. Okay. You should match that with highest temperature portion of hot stream, right? And what is this area? This area, 347.4 kilowatt. That is the difference between total area and this area, 347.4. And this is the highest temperature portion of cold stream. On the hot side, you look for highest temperature portion of hot stream. So, I put an E3 here, 282.27. E3. This is 347.4 kilowatt. Let's take a look. 310, 221. more than 11 degrees. 282, 179. You notice by going from bottom up, followed by going top down, we have taken care of those easy blocks for matching. What's remaining? Right? Only 2 remaining on cold side, 2 remaining on hot side, right? And we know we can put 3 more exchanger. 3 more exchanger, right? Now, there's no fixed solution to this problem. You might have different way of matching the remaining 2 blocks. You check finally average block temperature for each exchanger heater. Are they in good order? Okay, so now let's take a look. What is this remaining area? (1215.65). This remaining area, 968.19 kilowatt. How about this one? 259.53 kilowatt. And this is 282.8. How about this whole thing? 945.28. So, you look at here, this block, 282.8 kilowatt. You cannot put it there, right? Bigger. So you have to put this block. Suppose I put that as E4. Must be in this block, right? E4. The other thing you notice here, this average block temperature, right there, and this 945.28. 945.28. And 945.28, 968.19. This 205, 282, 205 is okay. 285, 93 is okay. But 968 only slightly bigger than 945. So, how do you take care of this? Because we can have 3 more exchanger. 3 more exchanger. E4, E5, E6. Right? On the top, you have E4, E5, E6. We know you cannot put E4 282 to here. So you must put E4 to here. You also need to match a little over here. So, what do we do?
Why did you go from the bottom up instead of the top down on the
You, you, to see. Okay? Bottom up, I see it easily, right?
No, the temperature, the actual temperature. Why did you decide to choose that? The fourth cold stream will cool the second hot stream from 212 degrees to 90
Okay,
degrees.
now watch here. This is the second highest temperature, lowest temperature cold stream, right? Second lowest temperature cold stream. Here's the second lowest temperature cold stream, right? So, you need to match the two. The area 996, I'll put that right there.
Why would you not write 996 from 244 degrees though?
Where? 9 is where?
Yeah.
No,
Why did you make the area?
I cannot put a top because that's the high temperature hot stream. We are now talking about low temperature portion of cold stream matching with lowest temperature portion of hot stream. You want to match this stream, right? Those two, right? Those are intermediate temperature portion of hot stream, right? You match the intermediate temperature portion of hot stream, those two. That's why I do not put it there. Are you clear? Yeah.
The thermodynamic patching rule, wouldn't the average temperature of the
Say that again, can I hear you?
for the thermodynamic patching rule, wouldn't the average temperature of the heater be less than the average temperature of the
Thermodynamic matching rule means highest temperature hot stream matching with highest temperature cold stream. Intermediate temperature portion of hot stream matching with intermediate temperature cold stream. Lowest temperature hot stream, okay, matching with lowest temperature cold stream. Thermodynamic matching rule, suppose you look at the plot. You have a hot stream. You have cold stream, right? So, you look at here. Say, this portion of hot stream requires cooling water, okay? This portion of cold stream requires steam, okay? Steam is always the highest temperature portion of cold stream. Cooling water is the lowest temperature portion of hot stream. You no longer have any cold stream. How about the other highest temperature hot stream? That's the way you match it, right? Vertical heat transfer, most efficient thermal transfer. That's why highest temperature portion of hot stream, highest temperature portion of cold stream. You have an exchanger here. You have a changer here, you have a changer here. That is the concept of thermodynamic matching. Do you see it now? That's why I'm doing it like this, okay? And for that, you can go from bottom up, you can also go from bottom top down. The way I want to do it conveniently is, I do not know where are the intermediate portion, where will this start, where will this end, I do not know. continue. Now, those two, right? There are different way of doing that. So, I can put, this is one way of doing it, okay? So, I take care of this one. E4. I took care of, what did I put E4? I have E4. Oh yeah, I need to take care of. So, I have this two block, but I need to put two exchangers here. The third exchanger. Here I need to put two exchangers. So one way I can do it is this hot stream. Alright. This hot stream want to match with this two cold stream. Right? Two cold stream. One way you can do it is split it. Split it. Okay? If I call this E4, E5. So, what I'm doing is, this single hot stream exchanging heat with two cold streams. So I split it. This flow rate is 12.53 kilowatt per degree C times E4 is 282.8 kilowatt. I get it from the cold block, 282.8. Over the whole thing is 1315. Over the whole thing, this is 968.19 kilowatt. 968.19, okay? This portion is 12.53 kilowatt per degree C. Minus A. A is this. This is A. 12.53 minus A. So, I match the two, E4, E5. Whenever you have one hot stream, you want to exchange heat with two cold streams, E4, E5. That's where the split comes in. One stream exchanging heat with two streams. Lastly, E6, and this happened to be E6. 945.28 minus E5. What is area E5? What is the area E5? Let me see E5. This. Okay. tell me 8.44 times 205 minus 93. Give me the number. 8.44 times 205 minus 93. What's the number? What is this total area? I think this might be an error. No answer? What is this total area? Yeah? That's correct? 945.3, that's correct? Okay, okay. So, and E5, so what is the area of E5 then? What is area E5? Okay, okay, let me see. This is 968.19. And this, okay, that's correct. That's correct. E5, E6. Okay. E5, E6. This is 1127.73 kilowatt. I think. Yeah. This E5, 968.19. And this E6 is 259.53. No, I'm right. Yeah.
The whole block for the C1 is the 945 number. It's not the 127.
The whole block of which one?
Of C1 is the 945 number. It's not 1127.
945.28?
Yes.
Then let me see. This temperature is 123.79. Okay? What should be E5? 205, 123.79. 8.44. What should be E5? I think I had it correct.
685.4. 35.
What's the number?
685.4.
685.4.
Yes.
685.4. How about E4 from E5 from the top? Or I do not know this yet. Okay, 968.79 minus 282.8. The difference between the two. Yeah, that's 685.4. Good. Done. E4 is 282.8. Okay? Done. E5, E5, E4, E5, E4, E6. Now, the last thing you need to check is average block temperature. Okay? So, E3, E4, E5, E2. On the hot side, on the cold side. So, you can check the temperature, write it down, and on the cold side, there's a hot stream average temperature, 205, 162, 366, 183, about 183. E3, this is no trouble because both are the highest temperature, right? So, E4, E5, E6, intermediate temperature. E4, E5, E6, followed by E1. No, followed by E2, and then E1. When you check this average temperature, there might be one. The order is not going from top down. That is okay, you can take it. For a 7-stream problem, you can violate the average block temperature ranking once, possibly twice. For 4-stream problem, you better not. You can try to make it all in the proper top down. Okay, that is the solution. I give you more problem to solve next week, but let me see how much time I have. Oh no, I got about 12 minutes, that's good. Let's go to page 65. When do we use stream splitting? Why do we avoid stream splitting? This is a very important topic. Why do we avoid stream splitting? And when do we use stream splitting? You look at this diagram, E1, E2 on the cold side. On the hot side, does it make sense on the cold side to put E1, E2 here? Why don't you put a bigger exchanger? E1 plus E2. On the top, merge them together. Minimize the number of units. On the cold side, it's easy to do. E1 plus E2, that's one block, one exchanger. On the hot side, E3 is one block. E1 plus E2, we split it. Split it. Okay? That's why you have to split. But now, splitting does not follow thermodynamics. Here's why. This temperature 2 is higher than 3. On the hot side, the average temperature is the same. Doesn't make sense. If you change for splitting, continue one block, vertical line to horizontal line. Then you find out 1, 1, in terms of ranking our average block temperature, this is perfect thermodynamics. Conclusion, if you don't have to use stream splitting, don't use it, because this stream splitting violates thermodynamic temperature, average temperature ranking. Then when do we use it? Next page. You see a problem here? I have one cold stream, 3 hot stream. Or you might have case 1 hot stream, 3 cold stream. So you heat up this cold stream, exchanging heat with 3 hot stream. You have no choice except to split it. Okay? When you have one cold, multiple hot, and this cold stream capacity flow rate, total flow rate, is larger than any of the hot stream. If this is a hot stream, those are cold stream, the similar situation. So, a cold stream with largest capacitor flow rate, okay, exchanging heat with multiple hot streams.
Is this because it would be expensive to bring in more of the, more streams? Like, you could theoretically bring in more cooling waters, like would it be more expensive to do so?
I only use a minimum unit with minimum heating utility, okay, in this case. Okay? And you want to talk about cooling water, then I need to change it to hot or cold. Now, in real practice, look at page 68. This is what we call fractionation column. Petroleum refinery. You have a cold, cool oil. Heat it up. Okay? Go to the bottom of this fractionation column. You have multiple products coming out. Okay, multiple products. So, essentially you have 1, 2, 3, 4, 5 fractionated product. This is going to go to a side stripping column with steam. So, you have one cold stream, multiple hot stream to cool down. And you need to use stream splitting. Okay? That's what happens when you're in a real situation in petroleum refinery. This, through the stream stripping, you get real product, okay, diesel, kerosene, naphtha, and other products like gas, like naphtha. Okay? This is when you need to use stream splitting. Okay. All right, now, next Monday, I cover beginning page page 70. Given one existing heat exchanger network, how do you improve it? Just show you one example on page 72. When you do pitch analysis, you find out QH mean, QC mean, number of unit. And people put base network like that. How do you simplify it? There's a few heuristic rules we're going to teach you next week. Now, Friday, if you do not do training, don't show up. You have time. Remember in the beginning of semester, in the course introduction, October 17th, you had a safety training. I received about 4 submissions so far. You need to do 6 online safety training, okay? Find time to do it, spread it out.